Okay, right. So without wasting much time, we should go into session 6. We have with us Professor Satya. Professor Satya, you are available right now?
Yes, sir.
Okay. So thank you so much. We have with us Professor Satya, who will be dealing with special concrete technology. I'm sure you would be gaining a lot from civil engineering department because over here we had been dealing with both the software and hardware yesterday and today. This is a more practical oriented one, and without civil engineering, no building is possible. So about the resource person, we have with us Professor S. Satya. She completed her PE in civil engineering in 1998 in Bharathidasan University and Masters of Engineering in 2014 under Anna University Regional Campus, Tirunelveli. She is well versed in structural engineering and has 13 years of experience in the well renowned SCAD group of institutions. She is right now serving as a associate professor of civil engineering department at St. Mother Teresa Engineering College. We are privileged to have such an experienced personality for our short-term training program of civil engineering. So we welcome you, Professor Satya, for this session on special concrete. Over to you, Professor Satya.
Thank you, sir. Thank you for introducing me. First of all, I would like to thank our management as well as Wollo University for giving me the opportunity to present the paper over here. A very good morning to one and all, and I would like to welcome for all present in the meeting. Sir, is my screen is visible? Sir?
Yes.
Is my screen is visible?
Right now it is not visible, ma'am, but it was visible. But can you share the screen once again?
Sir?
Ma'am, can you share the screen once again?
Is my screen visible?
Ma'am,
No,
if
only the
possible, can
chat
you switch
window.
off the fan, ma'am?
Shall I
The
start
fan noise
presenting?
is there.
Yeah,
Fan
visible,
noise is
ma'am.
there, ma'am.
Your chat window is visible.
Sir? Is my screen is visible?
Ma'am, Professor Satya, I request you to please off your fan if needed, because you can see, you can hear some background noise over there. If possible, you can off your fan.
special concrete and its application in construction industry. Before getting into the topic, we need to know
Excuse
what
me,
is
ma'am.
concrete. Concrete is a composite material. It is composed of fine and coarse aggregate bonded together with a fluid cement that hardens over time. Or it may be defined as it is a building material made from a mixture of broken stone or gravel, sand, cement, and water, which can be spread or poured into mold and forms a mass resembling stone on hardening. And what is special concrete? Special concrete is defined as concrete which meets special performance and uniformity requirements that cannot always be achieved routinely by using only conventional materials and normal mixing, glazing, and curing practices. Then special concretes or the concrete prepared for specific purpose like uh, for lightweight concrete, for producing high density concrete, for fire protection and for radiation shielding, etc. Basically, concrete is a very good material. It is a versatile material used in the construction industry. Concrete has high strength, high compressive strength, but it is weak in tensile strength. But it suffers from many drawbacks like low tensile strength, permeability to liquids, then corrosion of reinforcement, then susceptibility to chemical attack, and low durability. So we have to improve in so many areas. So areas of improvements are attempts are being made for rectifying the drawbacks by research works. Improvements in mechanical properties like compressive strength, tensile strength, impact resistance, and improvement in durability in terms of increased chemical and freezing resistances. Improvements in impermeability, thermal insulation, abrasion, skid resistance, etc. Then we should note the difference between an ordinary concrete and special concrete. So for ordinary concrete, it is used for normal works like building, then bridges, road, etc. For the construction of building, bridges, road, etc. In special concrete, it is used for special type of structures like nuclear reactor, buildings with acoustic treatment, air-conditioned buildings, etc. The ingredients for ordinary concretes are cement, sand, aggregate, and water. In case of lightweight aggregate concrete, lightweight aggregates are used in special concrete. And in polymer concrete, polymer binder is used instead of water. Then in ordinary concrete, construction is carried out by conventional method, that is by normal method, what we are following in the construction industry. Then for special concreting is done by special techniques. Then the properties of concrete like density, strength, etc. are of normal range for ordinary concrete. The properties of concrete like density, strength are of higher range. For example, the density of lightweight concrete is about 500 to 2000 kg per meter cube and that of heavyweight concrete is about 3000 to 5000 kg per meter cube. Then ordinary concrete is very economical, but special concrete is very costly. Then in the previous slide, I have mentioned about the special techniques used for concrete. Here we shall see some of the special techniques used for concreting. They are pumped concrete, shotcrete or gunite, and vacuum concrete. What is meant by pumped concrete? A pumped concrete which can be pushed through a pipeline under pressure is called pumpable concrete, or it may be defined as pumped concrete is the concrete which is transported to heights by means of pumping using concrete pumps. Here you can see the image of pumped concrete. The labor is concreting with the help of pumps. And this is also image for pumped concrete. The men are standing in a tall building, and they are using pumps for concreting. So, applications of pumped concrete. This method is used where large quantity of concrete work is involved at greater height, where other means of transporting is not easy to do. And concrete pumps have been known for more than 50 years. For the past 50 years, we are using this type of concreting technique. In modern times, large quantities of concrete can be transported by means of pumping through pipelines over appreciable distances, often to locations that may not be easily accessible by other means of delivery. The next technique is short lead or gunite. What is meant by short lead? Short lead or gunite is a master or a fine concrete that is pneumatically transported through a hole and projected onto a surface at a high velocity. It is suited for construction of lightly reinforced thin sections. It may not be suited for thicker sections or very deep sections. Then here is the image of shortlead and gunite. You may refer to YouTube videos for shortlead or gunite. There are plenty of videos available for shortlead or gunite. Whenever time permits, you can refer the videos presented in the YouTube.
Ma'am, excuse me, ma'am.
Then what is gunite? Gunite is a process used in construction for the application of slope stabilization and certain rehabilitation purposes, mainly in the construction of building walls, swimming pool construction, and tunnel construction, then including tank construction or water tank, and some of the concrete repair work. Basically, gunite is a dry process.
Excuse me, ma'am. Your voice is not properly audible, ma'am.
At the nozzle of the pump. So, skilled labor is selected for concreting this type of technique. That means gunite. This method makes use of a spray gun, and hence the process was made as gunite. A shotcreting process is called as the gunite. Hence, we are mixing water at the nozzle while spraying the concrete. Hence, it is known as dry shotcreting. Then applications of shotcrete or gunite. Shotcrete can be used to repair the damaged surface of concrete, wood, or steel structures, provided there is access to the surface to be repaired. Then the next technique is vacuum concrete. So it is suited for thin sections like slabs and walls have to be concreted. It is necessary to adapt a fluid mix with water cement ratio 0.5 to 0.65 to facilitate mixing and compaction. Then techniques adapted. A considerable part of excess water and air are removed by suction through a mat connected to a vacuum pump. Generally, higher workability and higher strength or very low workability and higher strength do not go hand in hand. This can be achieved in vacuum concrete. So this is a picture called vacuum concrete. So here, vacuum concrete is used for extracting the excess water. Here is a water separator. Here we can separate the water from the concrete matters. Here in the technology, vacuum is used to remove the excess water. Then advantages of vacuum concrete. Both workability and high strength are achieved simultaneously. That means we are adding a high percentage of water while applying, and we are removing the excess water by using the vacuum pump. So what is meant by workability? The mix can be easily prepared and placed and compacted. Then reduction in water cement ratio may increase the compressive strength by 10 to 50% and lowers the permeability. Then it enhances the wear resistance of concrete surface. The surface obtained after vacuum dewatering is clean and smooth due to reduced shrinkage. The former can be removed yearly and surface can be put to use yearly. That means the concrete will get easily hardened within a short span of time. Then types of special concrete. There are so many types of concrete: lightweight concrete, high density concrete, plumb concrete, no fine concrete, aerated concrete, fiber reinforced concrete, polymer concrete, ferrocement, high strength concrete, high performance concrete.
Satya ma'am, can you hear us?
Lightweight concrete.
Satya ma'am.
The density of conventional concrete is in the order of 2,200 to 2,600 kg per meter cube. This heavy sulfide will make it uneconomical structural material. The dead weight of the structure made up of this concrete is large compared to the imposed load to be carried. A small reduction in dead weight for structural members like slab, beam, and column in high-rise buildings result in considerable saving in money and manpower. Normally, the weight of conventional concrete is heavy when compared to the lightweight concrete. The lightweight concrete, the attempts have been made in the past to reduce the sulfate of the concrete to increase the efficiency of the concrete as a structural material. The lightweight concrete with density in the range of 300 to 1900 kg per meter cube have been successfully developed. Then see this image. The inference from the image is that in a roller support, both the conventional concrete and lightweight concretes are placed. The conventional concrete is placed in the right hand side of the roller and lightweight concrete is placed in the left hand side of the roller. There are two number of lightweight concrete placed in the left hand side of the roller, but when you infer from this image, the weight of the conventional concrete is higher than the weight of the lightweight concrete. Then how can we achieve the lightweight concrete? It can be achieved by three different ways. One, by replacing the normal mineral aggregate by cellular porous or lightweight aggregate. Then by introducing air bubbles in mortar, this is known as aerated concrete, and by omitting sand fraction from the aggregate, this is known as no fines concrete. No fines concrete means the sand particles will be avoided in the mixture or from the mixture of concrete. An advantage of lightweight concrete, reduction of dead load. Dead load means the sulfate of any structure or building. So we can reduce the sulfate of any structure. It is a greater added advantage to us. Smaller section of structural members can be adapted. So automatically the size of the structural member is reduced, the sulfate will also be reduced. Then lower falling and handling cost. The increase in the progress of work, reduction of foundation cost, particularly in the case of weak soil and tall sector. If we come across weak soil, we have to concentrate greatly on foundation. So it will cost much more higher. So the practical difficulty will come across when we execute some kind of work. Then lightweight concrete has a lower thermal conductivity. In case of buildings where air conditioning is to be installed, the use of lightweight concrete will result in better thermal comfort and lower power consumption. Then there are some more advantages. The use of lightweight concrete gives an outlet for industrial waste such as dryers, liquor, slag, etc., which otherwise create a problem for disposal. Nowadays, we are replacing the industrial waste, that is dryers, liquor, slag. It is brought from industry and we are using in the preparation of concrete. By replacing some percentage with dryers, liquor, slag, etc., thus we can reduce the problem of disposal, and we can also reduce the material, that is cement, sand and aggregate, by partial replacing with the industrial waste. And it offers great fire resistance. Lightweight concrete gives overall economy. Then the lower modulus of elasticity and adequate ductility of lightweight concrete may be advantageous in the seismic design of structures.
Ma'am, Satya ma'am, can you hear us?
So is it audible?
Ma'am, it is audible, ma'am. Right now it is very clear. Can you hear me?
Shall I continue, sir?
Ma'am, can you hear me?
Okay, sir. Advantage of lightweight concrete. The use of lightweight concrete gives an outlet for industrial waste. Thus, we can save the concrete materials, that is the concrete ingredients, that means cement, sand, and aggregate, by partially replacing with this. Then it offers great fire resistance. Lightweight concrete gives overall economy. The lower modulus of elasticity and adequate ductility of lightweight concrete may be advantageous in the seismic design of structures. Then application of lightweight concrete. It can be used for building decks of long span bridges, then fire and corrosion protection, then covering for architectural purposes, heat insulation on roofs, insulation of water pipes, filling for floor and roof slabs, construction of partition walls and panel walls in framed structures. The framed structures of the structure, it is built with column and beam. The load transference is from the slab to the beam and from beam to the column and column to the foundation. It is called as framed structures. So we can use this lightweight concrete for the construction of panel walls in framed structure, and these panel walls do not carry any self-weight because it is a dummy wall. The load transference is through slab, from the slab to the beam and from the beam to the column and from the column to the column footing. So hence it is a dummy wall and it can be used for construction of panel walls in framed structures. The natural lightweight aggregates. There are some lightweight aggregate. It is present naturally, as well as man-made lightweight aggregates are also present. Natural lightweight aggregates are pumice, scoria, rices, diatomite, volcanic tuff, and foamed lava. Then artificial lightweight aggregates are sintered fly ash, foamed slag, bloated clay, artificial cinders, expanded clay, slate, shale, coke grease, expanded perlite, and exfoliated vermiculite. The natural lightweight aggregates such as pumice, scoria, rices, sawdust, diatomite. What is pumice? These are rocks of volcanic origin which is naturally occur in the soil. They are light colored or nearly white and has a fairly even texture of interconnected voids. Its bulk density is 500 to 800 kg per meter cube. Then scoria. Scoria is lightweight aggregate of volcanic origin. They are dark in color. It is slightly weaker than pumice. That scoria is weaker than pumice. Then rices. It is also an waste material. The use of rices or groundnut husk has been reported as lightweight aggregate. Then sawdust. Sawdust is used as lightweight aggregate in the flooring and in the manufacture of precast elements, but the presence of carbohydrates in the wood adversely affect the setting and hardening of Portland cement. Then diatomite. Diatomite is a light colored sedimentary rock that is mainly composed of the siliceous skeletal remains of diatom. It is very porous rock with a fine particle size and a low specific gravity. Because of its porous nature, it is lightweight, but it is permeable. This is the image of pumice and scoria. It is naturally available lightweight material. Then this is the image of rices. We can get these waste from the rice mills. And this is the image of sawdust and diatomite. Sawdust, we can get the sawdust from the carpentry shop, and diatomite, it is a sedimentary rock and it is white in color. Then artificial lightweight concrete, sintered fly ash. For example, the example for artificial aggregate is number 1, sintered fly ash. The product is an excellent alternative to natural quarried aggregate. It is being strong, light, and consistent. Sintered fly ash lightweight aggregate substitutes the natural aggregate. So we can use the sintered fly ash for the substitute for the aggregate, natural aggregates or chips in concrete, thus reducing the dead bite. So it comes under the category lightweight concrete. This is the image for sintered fly ash. Then artificial lightweight concrete. The next one is the example for artificial lightweight concrete is foamed slag. It is a byproduct of produced in the manufacture of pig iron industry. It is a porous honeycombed material which resembles pumice. Then bloated clay. When special grade of clay and shales are heated to the point of incipient fusion, there will be expansion due to formation of gas within the mass. The expansion is known as bloating, and the product so formed is used as a lightweight aggregate. Then this is the image for foamed slag and bloated clay. So the foamed slag, it is a porous material. Then it is also lightweight aggregate. Then the next type is high density concrete. High density concrete is also known as heavy weight concrete. The high density, where the weight of high density concrete is more when compared to the conventional concrete. High density concrete is mainly used for the purpose of radiation shielding, for counterweights and other uses where high density is required. Then the density of the concrete, the density of high density concrete varies from 3,360 kg per meter cube to 3,840 kg per meter cube. Then the density of conventional concrete, that is the normal concrete weight, is about 2,200 to 2,600 kg per meter cube, and the density of lightweight concrete is about 300 to 1,900 kg per meter cube. From this table, we can compare the weight of high density concrete, conventional concrete, and lightweight concrete. The density of high density is concrete is about 50% more than the density of conventional concrete. That is why they are used in the radiation shielding. And this is the image for radiation shielding concrete blocks. These blocks are used for the special purpose radiation shield. And the main components of high density concrete are cement, water, aggregates, and admixtures. The admixtures are added to the conventional concrete for modifying the properties of concrete. Then the admixtures are water reducing admixture is used. It consists of lignosulfonic acid, carboxylic acids, and increase workability, reduce water requirement, reduces cement content requirement, high yearly strength. If you increase the workability, it is a very good property. When we add the admixture, it also reduces the water requirement. When the water cement ratio is less for the concrete, definitely the strength will be increased. The water cement ratio is directly proportional to the strength of the concrete. If the water cement ratio is reduced, the strength will be increased. If the water cement ratio is increased, the strength will be reduced. Then reduces cement content requirement, hence it is very economical. We can reduce the cement. Then the advantages: high neutron and gamma ray attenuation, then good mechanical properties, then relatively low initial and maintenance cost, then it is easy to construct. These are all the added advantage of high density concrete. Then applications of high density concrete. High density radiation shielding. It can be used for high density radiation shielding. Then it can be used as a precast blocks. Then it can be used for mass concrete project. Then high density concrete applications column. Then gravity seawall, coastal protection, and breakwater structures. Then bridge counterweights. Then ballast for ocean vessels. Then offshore platforms, noise and vibration dampening. So there are more applications of high density concrete. The next type of concrete is special concrete is aerated concrete. The aerated concrete is made by introducing air artificially. Artificially, the air is introduced in the aerated concrete. Gas bubbles into plastic cement mortar mix to produce a material with a cellular structure somewhat similar to sponge rubber. This is because of we are adding artificially air bubbles into the normal concrete. Then it is also known as gas concrete or foam concrete or cellular concrete. Then it is a mixture of water, cement, and finally crushed sand. The aerated concrete is different from air entrained concrete. The air entrained concrete is another type of special concrete. Though in both cases air is introduced into the material, but the rate of air is different in aerated concrete as well as air entraining concrete. An advantage of aerated concrete, it is economical. The low cost of material as well as the large dimension of block which have less weight ensure construction cost reduction. Because the size of the block is large, so we can reduce the number of blocks. Then low density, low thermal conductivity. Aerated concrete blocks have the density between 400 and 800 kg per meter cube. They are that is why they are light and warm. Then good acoustic protection. It is porous structure. Aerated concrete ensures soundproofing 10 times better than a brick wall of the same thickness. So when we compare the brick wall, the soundproofing is 10 times better. So it has a very good acoustic protection and fire and safety. Aerated concrete is a non-combustible fire-resistant material, has a first class of fire resistance which exceeds the one of the ordinary concrete. So it is a very good advantage. Then vapor permeability. It is a porous structure, so aerated concrete has good vapor permeability. That means it is permeable, means it is porous in nature. It will allow the water or anything else to penetrate into it. Then the house is made of aerated concrete, breathe, and the microclimate inside is comfortable. Then environmental friendliness. Aerated concrete contains natural, environmentally clean ingredients. Then the material does not release any harmful substances, does not age, and is not prone to decompose. Then application of aerated concrete. As load-bearing masonry walls using cellular concrete blocks, we can use the aerated concrete. What is mean the load-bearing masonry walls? The load is transferred from the slab to the wall and from the wall to the wall and then to the soil. This is the load-bearing masonry wall. The load transfer occurs by this means. Then as partition walls in residential, institutional and industrial buildings. Then the aerated concrete may be used as precast composite wall or floor panels, and it can be used as a pillar wall in the form of precast reinforced wall panels in high-rise buildings. Then as precast floor and roof panels in all type of buildings. Then it can be used as insulation cladding in exterior walls of all types of buildings. Then the next type of special concrete is air entrained concrete. So air entrained concrete contains a much lower proportion of air when compared to the previous concrete. Then the air entrained concrete is designed by taking the air entraining agent as the fifth material element in the concrete. That the mixture of concrete is a cement, fine and coarse aggregate and water. In addition to this, we are going to add the air. Then the air entraining agents are insol resin, Darex, and sulfated and sulfonated organic compounds, then animal and vegetable resins and fatty acids, then natural wood resins. This is the image of air entrained concrete. You can see the difference. When we compare with the conventional concrete, we can feel the difference between the image of conventional concrete and air entrained concrete. The air bubbles will be introduced into the air entrained. Then advantage of air entrained concrete. It has better workability, then resistance to chemical attack. It is not easily affected by any chemicals present in the air. Then less bleeding and segregation. Then light in weight. Then economical. Resistance for alkali aggregate reaction and reduced permeability. If the permeability is reduced, we can avoid many sort of problems, because if a concrete is very permeable, the water will penetrate through the pores present in the concrete. It will cause many problems when it is a reinforced concrete. Reinforced concrete means the rebars are embedded into the concrete. If the concrete is permeable, the water will penetrate into the concrete and it will cause corrosion problem. And if a rod embedded in the RCC is corroded, the weight will be increased and it will not do its work properly. That means it will not transfer the tensile strength. So, if we avoid bleeding, the strength of the concrete will be increased. Because in bleeding, the cement will bleed. And if we avoid or if we reduce the segregation, we can avoid the honeycombed structures. The honeycombed structure will be formed if improper compaction in the column as well as beam structure, that is in the structural elements. It will pose many problems due to the porous honeycombed structure. There will be a pores in the concrete, and the moisture or the moisture will enter into the concrete and it will pose many problems, and water will also enter into the porous material. Then advantage of air entrained concrete: better workability, Although air entrainment must not be carried out just to improve workability of the concrete, it can be regarded as a by advantage. When the workability will be increased means, if we increase the water cement ratio, the workability will be automatically increased. But for high workability concrete, the strength of the concrete will be reduced. Hence, if better workability, the concrete will not achieve the good strength. It can be regarded as a by advantage. Then the introduction of air bubbles in plastic concrete acts like a deformable fine aggregates. Then the strength and the slump of the concrete is related to the air entrainment, and considerable variation is never recommended. Then another advantage of air entrained concrete is resistance to chemical attack. According to research, the air entrainment for sure provides resistance in concrete against chemical and acid attacks. The air entrainment increases the acid resistance because the air voids block microcapillaries and prevent the acid from invading the concrete through these canals. The porous space or microcapillaries will be blocked in the air entrained concrete with the help of air. So the chemicals will not be easily thrown into the concrete. Thus, we can avoid the chemical attack. The same effect of air entrained concrete was confirmed by the Road Research Laboratory in the United Kingdom. And another advantage of air entrained concrete is less bleeding and segregation. So, as air entrainment in concrete enhances the adhesion between the concrete ingredients, so the segregation and the bleeding is considerably reduced by the introduction of air entraining admissions. There will be a specific or well bonding, so there will be no pores. Then bleeding, we know it is a process in which the water mortar emerges out on the concrete surface. That means from the mortar, the cement will emerges out on the concrete surface. While in segregation, the heavier materials settle in the concrete matrix. Both of these problems are resolved because of advantage of air entrained concrete. So thus we can avoid bleeding and segregation. Not avoiding, but we can reduce to some extent the bleeding and segregation. Then another advantage of air entrained concrete is then economical. When the weight of the air entrained concrete is compared with the normal concrete, the weight will be completely reduced. That means we can reduce 5% less solid and less light in weight. We can reduce the weight by 5%. Then economical, because of lightweight concrete, it reduces approximately 5% in the cost of cement and aggregate. Thus, we can reduce the material content as well as we can save the money. Hence, it is economical. Then another advantage of air entrained concrete is resistance for alkali aggregate reaction. Then air entrained concrete is found to be more resistant for alkali aggregate reactions. Then reduce permeability. So we can reduce the porous structure. Because of enhanced workability and uniformity of the concrete mass, the pore structure of the concrete is modified. The pore structure or micropore will be blocked by the air. So we can reduce the permeability. Then application. It is best suited in places of very low temperature since it is good at resisting freezing and thawing effects. For this reason, it was widely used in United States and Canada. Then it is not popular it is not popular in India because of our climatic condition, because India is a tropical country. So we never demanded the resistance to freezing and thawing such as in states. The air entering concrete has been found best suited for multi-purpose dam construction. Then the dams structures constructed using air entrained concrete are Hirakud Dam and Koina Dam. These two dams are situated in India. Hirakud Dam is present in Odisha and Koina Dam is presented in Maharashtra. These are the best example for the dam constructed using air entrained concrete. Then next, Plumb concrete. Large stones unto 300 mm size used in a normal concrete. In a conventional concrete, the size of aggregate used is 300 mm size. Hence, it is called plumbs. These large stones are called plumbs and it is used in large concrete mass. Then care must be taken to ensure that no air is trapped underneath the stones while mixing the concrete. Then the plumbs must have no adhering coating. Otherwise, discontinuities between the plumbs and the concrete may induce cracking and adversely affect permeability. If crack is formed, it will allow the water inside. Thus, the permeability of the concrete will be increased. Then it will pose many problems. Then purpose of plumb concrete. Plumb concrete is a special type of concrete which is usually done where the surface is uneven to minimize the costing of concrete. The practical example is below the footing of residential building, where in a small proportion where the slope of ground below single footing is 1:10 to 1:50. In that case, to save the cost of concrete plumb is usually preferred. This finally leads to minimize the construction cost of building in. Then the uses where it can be used. Plumb concrete is used at the water channel bed. Then it is used mostly in mass concrete work like construction of dam structure. Then it is used at side slopes of embankments to provide a protective layer to earthen foundation and bases. And the next type is fiber reinforced concrete. Then the fiber reinforced concrete is concrete containing fibrous material which is added to the conventional concrete. The purpose of fiber reinforced concrete used in concrete to control the cracking due to plastic shrinkage and driving shrinkage and reduce permeability of concrete, then reduce bleeding of water. Then some types of fibers produce greater impact abrasion, then shatter resistance in concrete. And types of fibers we are using day to day, we are using in the construction industry is steel fibers, glass fibers, synthetic fibers and natural fibers. Among these, steel fiber is best suited. Natural fibers are also very good, but the durability, when compared the durability property for the steel fiber is high, but it is very low for natural fibers because it will easily decompose or degrade. Then these are all some of the shades of steel fibers. Then applications of steel fiber reinforced concrete. It is applied for hydraulic structures, then airport and highway paving, then for industrial cores, then refractory concrete and foundation slabs for residential buildings. Then for constructing bridge deck, then in shotcrete lining, then in shotcrete covering, thin shell structures, then explosion. Then glass fibers. These consist of high strength, alkali resistant glass fiber embedded in a concrete mix. It can be incorporated into a matrix either in continuous or discontinuous chalk mix. Then the fibers will act as a reinforcement for the concrete matrix. Especially the fibers help to take the tensile strength. Then the properties of glass fiber: a high tensile strength, high modulus, then impact resistant, shear strength, water resistant, thermal conductivity, low thermal expansion, less creep with increasing time, then lightweight and low density, resistance to corrosion and fire endurance, and resistant cracks in concrete. The latest development trends in concrete technology emerging in India. Number one is building information modeling, that is BIM software. At the most basic level, BIM is a 3D design and modeling software that gives architecture, engineering and construction professional tools and insight into the planning, design, construction and management of projects. Then their specific benefits are improved communication and collaboration throughout the project and improved productivity, simpler and more reliable design process, then increased transparency of information, then earlier identification of errors, then fewer change orders, then shorter project timeline, then high quality product. Then intelligent equipment. Nowadays, IoT sensors and GPS trackers on concrete construction equipment can improve the production cycle and allow for predictive maintenance. Contractors can easily monitor the cement mixtures and other equipment for help receiving an alert when something is askew. Then problems can be addressed before they become a major headache and hold up a job. Then GPS trackers keep foreman up to date in real time when cement trucks are on the move. This data empowers foremen to plan jobs accordingly and react quickly, working around delays when they happen. Then the next trend is ultra high performance concrete. It is a new concrete technology, but that contains several novel ingredients, including fibers, but retains 80% of what makes up traditional concrete. Remaining 20% we can add some other material. Then off-site construction. Nowadays it is a trend. It refers to the design, fabrication and assembly of elements at a location other than at the actual site where they will be installed. Then precast and prefabricated concrete is one of the most common off-site techniques used during construction jobs. This approach used to be reserved for large projects, but it needs skilled labor. Here we are in lack of skilled laborers. Hence, the project completed should be very fast manner. Then advantage of offsite construction, improved efficiency, improved safety, cost reduction, speed, and more consistent quality. Then self-healing concrete, it is used for repairing the existing structures. Then graphic concrete. Visual interest and design are united in graphic concrete. This technology is used on precast concrete to create a patterned surface. Images can be applied as well. The concrete itself lasts just as long as the plain version. Then light generating concrete. Cement that can absorb and radiate light has been developed by Jose Rubio in Mexico. The cement can be created at room temperature, which is huge energy saver. It can light up roadways, bridges, bike path and more all without electricity. So how does it work? The cement absorbs solar energy during the daytime and emit light for about 24 hours. So in order for this to be possible, the crystallization in the cement was removed, so light could pass inside. It was replaced with a gel consistency. So we can save electricity also. So conclusion from this presentation is, as we look ahead, knowledge of new approaches, tools and innovative materials can make the difference between a winning and losing. Thank you.
Thank you, Professor Satya, for your intensive details with regards to concrete technology and its application in today's world. Uh, so, participants, if you have any queries, you can on your mic and you can ask your queries to Professor Satya. Participants, if you have any queries, you can on your mic and you can ask your queries. Dear participants, do you have any clarifications with regards to this particular topic? With regards
No,
to
sir.
the with regards to the application in the concrete industry? Right. So if there are no further queries, Dr. Prabhakar, you want to share anything?
No, sir. Actually, it's a presentation. Actually, I think she can't able to hear us. I think so.
Yes, yes,
But
yes.
her presentation is very good, sir. After some time, it's clear.
Yeah,
So
yeah.
thank you, sir, and thank you, ma'am, for your valuable presentation. And the morning also, the ma'am also she also presented very well. Thank you, sir.
Thank you,
Okay,
sir.
sir. Okay, sir.
Thank you, sir. Thank you.
Thank you very much, and thank you very much, Professor Satya. So once again, so we will be back once again in the evening session at 5 p.m. Indian Standard Time or 2:30 Ethiopia International Time. So this will be back with session 7 and session 8 with the Electrical and Electronics Engineering Department with the digital signal processing and more on MATLAB AI version in the future scope we will be dealing up. So thank you one and all. And
Can you share feedback, sir?
yes, sir. Yes,
Sorry?
sir. Yes, please. Yes, please.
Feedback.
Dr. Gosala, I think the feedback link has already been posted in the chat. Dr. Gosala, did you go through the feedback link that was posted in the chat box?
Okay. Once again, can you share, please? That is not visible. And
The second we
Sir,
posted in the
chat
chat
box is
box.
not available.
The chat box is available.
Yes, sir. Thank you.
Okay, fine. So thank you everybody. Thank you dear participants. Thank you dignitaries. Thank you resource persons. And thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, sir. Thank you, sir.
Yeah, Dr. Christo, sir, can you close the session, sir?
Yes, sir.
Thank you, sir.